All right. Okay, welcome to 1.2, solving exponential equations. Okay, this is your first step into dealing with exponents this year, so we are going to make it as smooth as possible for you. Okay, it's going to be a lot of calculator work, and we're going to be dealing with a couple of rules as well to help you guys understand how exponents work. Okay, so first thing I want you guys to do, we're going to get our calculators out because that's what we're going to be using for a whole lot of this section. Okay, might zoom out just a teeny bit more so you can see a little bit more of what I'm doing. Okay, see if we can focus that up just a tad bit. I don't want to, no, we'll keep it there. So, you guys can see, what we're trying to do on these ones is we have to solve basic exponential equations. Okay. Now, a lot of you guys might not know where some of these equation buttons are or what even to be doing. So follow along with me and I'll try and make it as simple as possible. Okay? So, the first thing I want you guys to do when we have a graphing calculator is that it looks very visually similar to what you need to do, what your paper will look like. So what I mean by that, see we have a 1 squared here. So 1 squared, all I want you guys to do, type in 1, and there's this little caret here. That is going to be your exponent button. Okay? And see how it raises it up a little bit higher? Press 2, and then press enter. You guys can see that it's a little bit dark. I'll try and scoot it over. And you can see here, I get a 1. So that's just my answer. Okay? Then we go on to our next one. We have 5 squared. Do 5, caret, 2, press enter, and we should get a 25. So let's go to our next one. 7. 7 to the second power. Press enter. And that's 49. All that's really happening here is that we're saying 7 times 7. And we're saying 5 times 5. 5 times 5 being 25 and 7 times 7 being 49. Let's go on to a bit bigger number. 11 to the second power. Again, press enter. What do I get? 121. Go to your next one, which is 8 squared. Okay. Now 8 squared, I type in 8 to the second, press enter, and that should give me 64. Hopefully that looks a tad bit better. It's still kind of a little blurry on that side. I might try and center this a little bit more. Okay. Our next one, we have 4 to the third. Now this is the first time we haven't pressed the 2, but it's the same idea. We want to press 4 first, which is our base number, then this caret, then 3. Okay. Once again, you're going to see that gives us 64 as our answer. And do the same thing with the following. 3 to the third gives us 27. 5 to the third gives us 125. 2 to the fifth is the same idea, only this time we put a 5 as our exponent. You guys can see that. Instead of a 3, press enter. That's 32. Then we want to go over here and do 10 to the fifth, which is 10. Right there, to the 5. Press enter, and we're going to get a big number this time. 1, 2, 3, 4, 5 zeros. So we're going to do 1, 1, 2, 3, 4, 5 zeros. Right there, 100,000. You guys want to put a comma there so you can see a little better? That's what it should look like. Okay. Now, let's go over a little bit of what's coming next to us. Okay. What we have here is the product rule for exponents. So exponents, just like multiplication in normal numbers or regular numbers, has rules to it. Okay, exponents are a little bit different. So when we're talking about exponents, the numbers themselves, the x's themselves, are the things that are being multiplied together here. There's obviously no space in between, and we're basically saying I have 5 x's over here and 2 x's over here. How many x's are being multiplied together? Well, that's just 5 plus 2. So it's the same thing as basically saying x and 5 plus 2. Okay, and if you guys can do that quickly in your head, that's just x to the 7th power. All right. All right. If you guys want to see an example of this, I would do something in your calculator real fast. So, my first thing I'm going to do here, just to show you what I mean, I'm going to use 2 as an example problem. Go 2 to the 5th, and then do 2 to the 2nd right afterwards. What number do we get when we press enter? Well, it's 128. So now I want you guys to do something. Do 2 to the 7th power and see what you get. Also 128. So yes, this is in fact true. You add your exponents when you multiply is the rule of this. Okay? Now, the next thing I want you guys to do is a little bit more visually oriented. Exponents are just shorthand multiplication. So how I can actually rewrite this is saying I have 2 x's here and they're multiplied together. So I'm going to do x times x up top. And for the bottom, I have 5 x's that are being multiplied together. So I'm going to do, zoom in a tad bit here, try and refocus that, just so it looks a little bit sharper. Okay, and I have 5 x's here. That's x times x times x times x times x. 1, 2, 3, 4, 5. Okay, now division is basically canceling. What you want to think about is if I cancel those, how many am I left over with? Well, I'm left over with 3 on the bottom of the fraction. So if I have an x and 3 x's right there, what could possibly be happening at the top? Well, if you guys can remember, division, if I cancel something out, all I'm left over with is 1. Not 0, there is still an imaginary 1 that kind of just lingers up here a little bit, okay? And that is going to be my answer. Now, for those of you guys that can think about it a little bit, could I have not just said 5 minus 2 and gotten 3? Just a hint, if you guys want to, you can always subtract your exponent, you can always subtract the smaller exponent from the bigger exponent and leave it to where it got subtracted from, okay? Now, the next rule that we're going to be dealing with is called the power rule for exponents. So the power rule for exponents is a little bit different than how we would do the product rule for exponents. Okay? So, in the product rule for exponents, we talked about how you add the 2 together, right? Now, power rule is a little bit different. When we have a parenthesis around one exponent, and then we have a 2 on the outside here, it's the same thing as doing x times x to the 5th times 2, like that. A little bit different. So our answer is going to be x to the 10. Now the power rule only applies when we have parentheses surrounding one of our exponents. Okay? And now we have to deal with the negative exponent rule. So, how I like to think about it is that if I have a negative exponent, it's below the surface or underground or something like that, or however you want to think about it. It's the same thing as saying 1 over x to the 5th. Okay? So if you wanted to go back, you can even reverse this one. It's the same thing as saying it's the same thing as saying x to the negative 3 is also the same thing. They're equivalent, okay? 1 over x to the 5th. So whenever we have a negative exponent, what it really means is that it's going under a 1 on top. When I'm dealing with this one right here, I want you guys to think of it as saying it's 1 over 7 squared. Now if you want to, you can always type it into your calculator just like this. Press 7 and then the caret again, right there, to the negative 2, and press enter. Now it's going to give you a decimal. Remember, we're not supposed to get decimals here. So I want you to press the math button, and that very first one where it says fraction. Press enter, and look what I get. 1 over 49. And that's your answer. Okay? So, we are now going to use our skills to solve equations that look really awful, but are really not that bad as long as you remember the equality property up for exponentials, which is as long as the bases are the same, okay, are equal, is more what it would be a better term, are equal, the exponents must also be equal. So what do I mean by base? Well, a base is the bottom number here in your exponent, right? So if I'm looking at example 1, here, 8 is the base for our exponent. So as long as the bases are equal, what I want to do here is find 64, but as an exponent with a base 8. What does that look like? Well, here's what I want you guys to do. I want you guys to start typing in exponents, starting at 1, until you get to 64. Okay, 8 to the second, and all of a sudden I have 64. So another way that I could write 64 then is 8m equals 8, oh my goodness, 8 to the m equals 8 to the second. Okay, now here's where we have to read our rule. As long as the bases 8 and 8 are equal, which they are, the exponents must also be equal. So if 8 and 8 are the same, then m and 2 must also be the same. So it's easy enough for me to say that m is equal to 2. Just like that. Okay? Now, let's go to b. B is a little bit different, remember. We want to rewrite this equation, but after using our power rule. And if you can remember, power rule is when we use parentheses when we have parentheses around our exponent. And it's multiplying those two together. So here, I'm going to rewrite this other side here as 3 to the 4p minus 1 equals 3 to the 5 times 7. Now 5 times 7 is just 35. Okay? And once again, let's refer to what it says. As long as the bases are equal, the exponents must also be equal. Okay? So for us, we can look at this, and we can say that 3 and 3 are obviously the same, so that must mean that 4p minus 1 and 35 are the same. So all I'm going to do is rewrite it as 4p minus 1 equals 35. Add your 1, just like we would in a normal equation. There you go. 4p equals 36. Divide both sides by 4. And p equals 9. And that's your answer. So, let's move on to our next one. There is going to sometimes be some solving. Currently, I can't turn this into an exponent just quite yet. I need the exponent to be alone on its own side. So in order to do that, I want us to add the 100 over to the other side. That's our first step. Now those 100s are going to cancel, and that should leave me with 10 to the 3x minus 4 equals 10,000. Okay? Now, here's where we have to go and combine what we did in the previous problem with the guessing the exponent and doing this where we actually had to solve it at the end. Okay? So, what I want you to do, get your calculators, guys. Let's see if I can get that there. All right, and we're going to start getting something so that 10,000 has a base of 10. Okay? Those are our two bases. So, if I do that, let's start at 10 to the 1 and see what we get. 10, 100, 1,000, getting closer, 10,000. Since those two numbers match up, 1, 2, 3, 4 zeros and 1, 2, 3, 4 zeros, that is what our 10,000 can be turned into as an exponent. So I'm going to rewrite this as 10 to the 3x minus 4 equals 10 to the 4. And just like we talked about on our previous problem, if the exponent bases are the same, and our base is 10, and our base is 10, then that must mean that 3x minus 4 and 4 are the same. So I'm going to do that here. 3x minus 4 equals 4. Okay, add your 4 to both sides. Our 4's cancel. We get 3x equals 8. Okay, divide both sides by 3. Your 3's cancel. Now I want you guys to do something for me. Okay, I want you to go into your calculator. If you haven't seen this in my previous notes, it's a very simple task to determine whether or not this is a reduced fraction. Press alpha, y equals, where it says n and d, numerator, denominator, press enter. And you guys can see here, is this not kind of laid out as a fraction? Put 8 and 3 here, press enter, and you can see it doesn't reduce, so that is going to be our answer as x is equal to 8 over 3. Alright, let's move on to our last couple here. So we're going to combine everything that we know up to this point. Okay, so remember, 625, but we want it as base 5. Actually, I'm going to go back and do all of that. Base 8, base 3, this one's going to be base, base 10, okay, so that's going to be base 8, base 3, and base 10. This one's base 5. So what we need to do is get 625, but it has a base of 5 instead. So again, start typing in your exponents. 5 to the 1. You guys can kind of see here. It might be a little bit easier. Remember, it's this button right here. 5 to the 1. Enter. That's 5. 5 to the 2. It's 25. 5 to the 3. 125. Getting closer. 5 to the 4. Well, that's 625. So that's what I'm looking for here is a 625. So I'm going to rewrite my equation as 5 minus n minus 3 equals 5 to the 4. Okay? And once again, are my bases equal? Yes, they are. They're both base 5, so I can just rewrite my equation as minus n minus 3 equals 4. Add your 3 to the other side. Those cancel. I'm left with a negative n equals 7. Okay? Now, a quick trick. I'm looking for a positive n, correct, as an answer. So if negative n equals positive 7, then positive n equals negative 7. All right. Let's move on to our next bit. 7 to the 2x power and 1 over 49. Now again, we are just going to have a base of 7. Now, the trick to understanding this, guys, is instead, don't look at this as a fraction, but look at it as at what the 49 is. Let's try and get 49 into a base of 7. Okay? So, how am I going to do that? Using our calculator again. I'm going to go 7 to the 1 power, not the 4, the 1. Press enter, that's 7. I'm going to go 7 to the 2nd power. That's 49. Is that the number I'm looking for? It is. Okay, now what I want you guys to do, rewrite your equation as 7 to the 2x equals 1 over 7 to the 2nd power. Okay. Now you guys might still have a little bit of an issue with this. I want to refer to the problem that we did at the beginning with the negative exponents. Okay, so let's zoom out a teeny bit. So you can see up here where it says x to the negative 5th equals 1 over x to the 5th. So you can see all the negative did was bring my exponent down to the bottom under a 1. And you can see here 1 over 49 is the same thing as saying 7 to the negative 2. Okay, So if I could write this as a different thing, I would write it as 7 to the 2x equals 7 to the negative 2. From there, my bases are the same. Rewrite it as 2x equals a negative 2. Divide both sides by 2. X equals a negative 1 is my answer. Okay? All right. Let's come back, bring it back in. A teeny bit. Okay, we got another one where it looks as if we need to have, focus there, where we need to figure out what 64 is on the bottom, and we're going to make sure it's a base 4. Okay, so first thing I need to do, get my calculator out, guys. Start putting numbers in. 4 to the 1. No, 4 to the 2. That's not it. 4 to the 3. 64. That's the one I want. Rewrite it as 1 over 4 to the 3 equals 4 to the 5x minus 7. Remember, I can rewrite this as 4 to the negative 3 equals 4 to the 5x minus 7. Okay. From there, you will have to rewrite it again as negative 3 equals 5x minus 7 and solve. Add your 7. 4 equals 5x. Divide both sides by 5. Okay, if you guys are still having trouble with this, I would encourage you alpha y equals numerator denominator 4 and 5. Press enter. Doesn't have to reduce anymore, so I'm just going to rewrite this as x equals 4/5. And that's my answer. Okay. Hopefully that was helpful. If you guys need anything else, be sure to ask your teachers.